Okay, Assalamualaikum. Hi. Okay, let's continue to the other sections of chapter 2. Okay, so now we are going to look into the other types of 2D plots that are available in MATLAB. Actually, in MATLAB there are many other ways for you to represent your data. Usually it was depending on your situations, so you might want to consider or use these techniques which might be more appropriate to represent your data rather than using the simple XY plot. Okay, so these are the different variations of 2D plots that were available in MATLAB. The first one is polar plots, and logarithmic plots, bar graph, pie charts, histograms, and then we also going to look into how we can do or how we can create XY graph but with two different y axes and also the function plots. First, let's look at the polar plots. For some functions, it is easier to specify using polar coordinates than by using the rectangular coordinates. So this is the syntax if you want to create a polar plot. First, you should type polar and then followed by the round bracket, which indicates the input arguments that you are going to specify. In this case, the compulsory input needed are the theta and radius. You can also specify the type and color of line and markers that you are going to use. Okay, so let's try this example. We know that the equation of circle is y equals to sine x in polar coordinates. So we are going to recreate this circle in polar coordinates. Okay, first you have to initialize the x vector. So x will be from 0 until pi with the step size of pi over 100. Okay, and then this is the equation y equals to sine x, and then this is how we call the polar coordinate function, polar x y. And then you can also include the title. Okay, once your character string has turned to this purple font color, it means that your character string is inserted properly. Okay, so next I can run this section. Okay, and then you will get this figure 1 window which show the circle in polar coordinate. Next is the logarithmic plots. Okay, for most plots that we have generated so far in this chapter, we are using the x and y axes that are divided into the equally spaced intervals, which we call it linear or rectangular plots. So occasionally we may want to use log scale on one or both of the axes. So we can do that by using this logarithm scale plot. It is convenient, especially if we want to represent the data in a wide range of values, and it also will provide a tool for us to identifying the characteristics of data and the possible forms of mathematical relationships that can be appropriate for modeling the data. Okay, so the bold font here show that this is the MATLAB commands that you can use for making the plots. Okay, each of these has a different meaning. For example, okay, this is the normal plot xy, the linear scale 2D plots, and then with semi-log y you will use the log base 10 scale on the y-axis. Meanwhile, the semi-log x indicates that you want to use the log base 10 scale on the x-axis. Meanwhile, if you type the command log xy, it means that you want to use log base 10 scale on both of the x and y axis. Okay, let's look at the example here. So here I have the example of a logarithmic plot. This time I show the difference between the two plots in a subplot command. Okay, it means that I divide the figure window into these 4 different sections, and each of this section will show the different use of plot and semi-log command. Okay, let's try the first one. First, obviously, you have to define the x and y vector here. Okay, then enter the command for creating a subplot. Okay, in this case, we want to create 2 rows and 2 columns subplot. So we start with the command subplot. The first input field here is for you to indicate the number of rows that you want to create. The next field is for you to indicate the number of columns that you want to indicate, and the number 1 value here is referring to the first plot that you are going to create. Following this subplot command, okay, we type this plot xy. This is to show the first linear scale 2D plots. Okay, and then you can insert the title and y labeling, and you can also turn on the grid. Secondly, I'm going to copy from the first subplot, okay, and then you edit it accordingly. Okay, first we edit the subplot command. Okay, we edit the third input arguments. Next, the command. Okay, we now want to use the semi-log x. Okay, we want to use a log 10 base scale on the x-axis. Okay, leave on the title and y labeling and also the grid. Next, let's create the third plot. Okay, so you obviously just change the third input field and also the command. Okay, this is semi-log y. Okay, the previous should be log linear, the title, and the third plot should be the linear log. Okay, so this one semi-log y, and the labeling, you want to label, this is the third graph. this is the first graph, this is the second graph, this is the third graph, and this is the fourth graph. Okay, linear log, alright, and x label should be changed into, okay, and finally our last plot, change 3 to 4, and the command should be log log, and the title is a log also, x label, and then now we include y label. And let's try run this section, and then you'll get this floating window that show the different definition of the different command to create logarithmic plots. So this is the first graph, second graph, third graph, and fourth graph. Next, we have the bar graph and pie charts. Okay, so in MATLAB, it has a whole family of bar graph and pie charts, and these are bar x, bar h, bar 3x, bar 3h, pi, and pi 3x is all the MATLAB command that you can use to create all these different graphs. Okay, bar x is the, for example, is for you to create a vertical bar graph. If you want to create the bar graph horizontally, just include h at the end of the word bar. And we also have the 3D types of vertical bar graph, but you have to include the number 3 at the end of the word bar. And you can also do the 3D horizontal bar graph by typing bar 3h, and then pi x is for you to create pie chart, and then pi 3x is for you to create a 3D pie chart. Okay, let's try this example. Okay, first let's define the x and y vector. Again, I use the subplot to show the different variety of bar graph and pie charts available. Okay, so this is for the first one, and then you can include the title. And then the second graph is subplot 2 to 2. So here we are going to create bar graph of vector of matrix Y. Next, okay, subplot 2 to 3 is a 3D vertical bar graph, and then change the title. And finally, subplot 2 to 4 is a pie chart. Okay, then you can run section, and then you will get these different types of bar graph and pie chart. Okay, the first one, second one, third, and fourth. Okay, next let's look what do we have. Okay, and we also have histograms. Okay, so a histogram is a plot that show the distribution of a set of given values. So the overall range of a given set of data point is actually divided into smaller subregions that we call in bins, and the histogram shows how many data points are in each bin. Okay, so let's say for example we have this vector x here is a recording of a daily maximum temperature during the month of April. Okay, so type this data manually on your editor file, or I have it already here. Okay, then HISTY is the command for you to create histogram, and then we can run this section. Okay, so this is the histograms that is created by MATLAB. So by default, MATLAB will divide the data points into 10 bins. Okay, the first bin is here 1 2 3 4 5 6 7 8 9 10. So the range, okay, the data range started from the smallest value of recorded temperature, which is 48, and the largest, which is 93, which means that the range started at 45. Okay, then because the default is 10 bins, so 45 divided by 10, so the width of each bins here is 4.5. Okay, so the range for the first bin here, the range started from 48 until 52.5. Okay, so here from 48 until 52.5, it contains 2 data points. Okay, you can check your data set given. From 48 here until 52.5, there is 2 data points. Okay, and then from 52.5 to 57, okay, this is the second bin. It has 3 data points, and so on. We also observe that there are 2 of the bins, okay, from 75 until 79.5, and also from 84 until 88.5 do not contain any points. Okay, so this is how you can use the histogram to represent your data. Okay, next let's look at how we can create an overlay of two XY plots into the same figure. Okay, let's look at this example. We have this vector x range from 0 until 2 pi with an increment of pi over 20. Okay, we want to create the two lines here. Okay, the blue lines is the sine x, and this red line is the exponential x. Okay, you can see that here, okay, it is very hard to observe the characteristic of each lines. Okay, so you know that first let's try this. Let's try plotting the sine x plot. Okay, you know that when you try to plot x and y1, you will get this kind of lines. Okay, but here you just observe the blue line act like a straight line, which is not really accurate. Okay, it is because it has the difference in the values for the y-axis. Okay, so the value for y-axis is really small compared to the y-axis for exponential x, which is in hundreds. Okay, so it is hard to represent the blue line here. Okay, the range of y-axis is really small. So when you plot it like this, you will get this kind of graph. Okay, the problems come from the scaling of the y-axis. Okay, so to avoid that, okay, to make the data or the line possible for us to observe the real characteristic of the data, we can use the plot yy function. Okay, this plot allow us to use two different scales on a single graph. Okay, so here when we use plot yy, so I just continue defining my x2 line, exponential x, and then I straightly type command plot yy, and then here you have to use the multiple input arguments. Okay, x, y1, enter it in according to which set. Okay, according to which order. Okay, so the first order is x, y1, the second order is for x and y2. Okay, and then run. So you will get this graph. Okay, so you can easily differentiate the two lines, okay, between the red and blue lines. Okay, so you can also add the title and labeling for this figure. So to add labels, you can use the previous method of using MATLAB commands. Okay, by just typing the title, x label and a y label like this. Okay, so we have left label and the x-axis label, but how do you add the labeling for the right axis? Okay, the red axis here. Okay, you can do that by giving the plot a name, which we also call a handle. Okay, so here previously we just type plot y, and now we will assign a variable name to this plot yy, and then after that we can use the y label command. Okay, but you have to specify the variable name. So inside the input argument for y label, you type a is the variable name of this plot, and then 2 here indicates the second axis. Okay, so you type your labeling name in this character input. Okay, character means this font line here. Okay, whenever I say character type data input, it should be enclosed in between this apostrophe, and then close the input argument, and then you can run the section. Okay, now you can label both of the y-axis. Finally, we have the function plots. Okay, function plots is actually quite similar to the plot commands, except that you can, with function plots, you can use a function as input to a plot command. Okay, so for example here, we can use function plot to plot a graph of sine x. Okay, so you can strictly type the function. Okay, mind you, sine x is a built-in MATLAB function, so that's why you can use this function plot to create a graph. So the range, okay, the second input argument for function plot command is for you to insert the range of the independent variable. In this case, our independent variable is x. Okay, so another thing is the function input, okay, you should insert it as a string. Okay, it should be enclosed in this apostrophe. So the range would be from -2 multiplication sign from pi until 2 pi. Okay, the range should be entered as in the matrix like this. Okay, use the square bracket and then close the input arguments. Okay, and then just run. Okay, so this is the sine x graph from -2 pi until 2 pi.